Can students
I
see?
am going to go back to
introduce the
okay.
whole program as if you are presenting it to the High Commission. You have to take it one step at a time, like the brochure you did. Introduce yourself about exactly like what we discussed before. And you can stop and ask questions to them or ask questions to Miro so that it become a group presentation. It's much easier for you.
Okay. We're gonna go back to that. Okay. So, like I said, my name is Gabriel Zencha. I'm a fourth grade computer engineering student. I'm in the final year of my studies, and I've been working on a smart home project for more than 6 months, and I am still working on it because it's going to be my graduation project. Okay, so like today, I am about to introduce you to a technology, but before we get to this technology, I would like to tell you some of the popular things that one of the sayings of the second richest person in the world, like I told you earlier, Elon Musk. He recently said the greatest threat to humanity is artificial intelligence. Okay? And artificial intelligence, how is it a threat to humanity? You are students of FEM Foundation, right? And you're studying computer science. So, do you know what is artificial intelligence?
Technology that is able to function so without
Human.
So it's technology that can function on its own without any human help or instruction.
Yeah, perfect. That's great. So artificial intelligence, we're talking about machines making decisions without the help of humans, making decisions on their own. Okay? So you have a brain. This brain permits you to make decisions. But artificial intelligence is a computer having a brain, and that brain permitting that computer to make decisions. Okay? So let's just say you came to school today and you were late in school. And maybe your discipline master sent you away because you came late to school. So just imagine your discipline master now in the future is a robot standing at your gate. And once you come, he tells you, you cannot enter into this school. Go back home. Okay? So that is the problem that we are going to face. Machines are going to take control of so many aspects. In our health, you go to the hospital, maybe computers will be the ones treating you. In learning, maybe your teachers in class will be substituted by computers to teach you. Okay? But how can we prevent this? Do you have an idea on how we can prevent this?
While the students are thinking about this, maybe can we introduce them to another example? The risk of AI to humanity is actually the artificial intelligence games in the house.
Yeah.
So that is extremely destructive, addictive.
Yeah. So many of you have phones or maybe computers. Or once you go back home during holidays, you have computers at home. Yes. What do you do with your computers?
Sometimes I try to write HTML pages.
Okay. Sometimes you try to write HTML pages. That's a good example. But I'll tell you that right now, one of the highest industries making a lot of money in the world is the gaming industry. Okay? Do you know why they make a lot of money? Because the population is addicted to games. Okay? The population, everybody is addicted to games. I stayed with my father. At night, he sits, he's playing games. Once you speak to him, he doesn't listen because of games. All his mind is focused on games. Okay. With the pandemic situation, I will tell you that in the developed world, the rise in games, gaming has been on the rise. So we have students staying at home, not learning, not listening to their parents, okay, and just playing games all day. This has caused so many parents to like I don't know if you know stress. So many parents are stressing
Depression.
because they have fights with their children, depression. They are depressed about what is happening. Is this the life of our child? Is this the life we want for the child? The life where you wake up and you're playing games all day. This is not what they want. Okay, that is an example of artificial intelligence working. Okay, why? Because they've made you get so much into the games that it is difficult for you to come out of it. Okay, but I'll tell you, artificial intelligence can also be used for your good. Okay,
Yes.
it can also be used for your good. So we are trying to show you how artificial intelligence can be used for social good. Okay, not to give your parents depressions or not for you to get addicted, but for you to be able to help communities, for you to be able to provide energy to your community. Right now, we don't have electricity, right? You don't have. This is what happens in Bamenda. Yes, this is what happens in Bamenda. You don't have electricity all the time. There are periods you have electricity. There are periods you don't have electricity. Okay. So this is a problem which you have to solve, which we have to solve. Okay. But how can we solve this problem? Any idea?
Using solar.
Okay, you're using solar. That's good. Okay, that's good. But using solar is not enough. Okay, we can use solar, right? But once we are using this solar, how do we regulate our appliances? How do we make sure that this solar energy we are using is enough for us? We are able to use it throughout the day. That's where you hear about microchip programming. Okay, so we need to program microchips. We need to be able to program these devices to help us for social good. Okay, and I will tell you that being able to program microchips is the same as artificial intelligence. Miro is showing an example of a microchip. Can you
Here are the microchips. This is a controller and
Okay.
stem cell controller, and it is actually connected to various inputs and outputs. And on the top, we actually have a Wi-Fi chip. So this Wi-Fi chip is able to connect wirelessly into the network, into the local network, and then even onto the internet. So that means that this Wi-Fi chip can actually also host a control web page, which we developed. This control technology, IoT and AI, is called RunLink, and it is inside this Wi-Fi chip. Because it is inside the Wi-Fi chip, it can also then, the Wi-Fi chip can piggyback and control onto the controller. So it's like having a fly on an elephant. This can lift many things. So with the blue wire, it can even switch a relay box, which can then switch a lamp. Okay, so the blue wire is connected to a lamp. We have inputs such as light sensors and buzzers as well. So this is the microchip computer, and this is a Wi-Fi chip microchip computer as well. Okay, and I think that Gabriel will show you the control web page, which is inside this microchip.
Okay.
Do you have that open, Gabriel?
Okay, thank you very much, Miro. So he has introduced you to a microchip, okay? He has shown you a microchip. And like I told you, my graduation project is about programming microcontrollers. And I have been working on such a project for 6 months, more than 6 months, okay? And today you're going to see something which I tried to achieve in these 6 months to program this microchip, and I had to write 600 lines of code. Like I'm telling you, more sentences to talk to this device, to tell this device how to operate, okay? But today you will see how easier it is to do it using with just 6 lines of code, okay? Yes. I ask you, what is the difference between 6 and 300? 294. Okay, 294. And I'm a computer engineer. I've been studying, working on this microchip programming for a long time. I have experience on this, okay? But I wrote 294 useless statements, okay? Statements that are not useful, statements that give me headache, that could not let me sleep, okay, for 6 months, but they were useless, okay? So today you're going to see what I tried doing during this period with this much sentences in just 6 lines of code, okay? And this is how technology has to be, okay? You will see how easier it is and how you yourself can use such a technology. How old are you? Maybe you're 15 years, 14 years, 13 years, okay? You will see how you yourself, you can use such a technology, okay? You don't need to be in a university like me. You don't need to be a computer engineer like me, but you are able to use such a technology, okay? So, Miro, can we head on to the demo, or do you have something to add, Dr. Feng?
Just briefly, before Miro show you the 6 lines, what Gabriel has described to you in terms of artificial intelligence equals to microchip programming. That is a very important formula. So relating back to Elon Musk, saying that artificial intelligence is the biggest risk to humanity, sounds like life depends on AI. And I'm sure Gabriel will be able to prove it, right? So that confirms Elon Musk is correct. But at this point, it is important to understand artificial intelligence also equals to microchip programming, right? It's like a formula with artificial brains equal to microchip, which is empty, and then intelligence equals to programming. So therefore, microchip programming equals to artificial intelligence. So everywhere in the world you see a microchip is actually AI. So what you are seeing next with Miro demonstrating, the 6 lines is all you need to put intelligence into a web page that will turn into a controller to let you turn lights on and off for an intruder alarm. As Gabriel has explained, it took him a few hundred lines in order to do the same thing. And he's studying in Turkey. Cost him a lot of money to go there to study, right? So you are very lucky that Gabriel is there to share his real experience, because he is going to graduate soon in 4 months' time as a computer engineer. So this is a huge opportunity for firm foundation students to understand that you are going to be the pioneers to solve the problem of Elon Musk. Because as Gabriel said, we use artificial intelligence, microchip programming for social good, like make an intruder alarm for your house, for a smart home, yeah? And then you can also help the girls to learn this so that there is gender equality. At the moment, there is a huge imbalance in Australia. Only 10% of girls are into STEM subject. And STEM subject is so important. So where there is 100% boys, there's only 10% girls. So we want to use this technology that you're going to see next to increase the girls from 10% to 100%. So we'll double the human resource. 100% boys, 100% girls is 200%. Not 100% boys and 10% girls is only 110%. So when we double the human resource, what do? We build smart schools. We build smart farm. We build smart health. And obviously, Central University Institute of Bamenda has the ability, when you complete your secondary school, to continue your journey. But you already have a head start of many years compared to other students in other schools, which do not have this opportunity, including schools in America, schools in England or Canada. They don't have this opportunity to learn because it's confirmed by Gabriel. Turkey don't have this. Yeah, even at uni don't have this, let alone in secondary school. So I let Tamiro to carry on to show what you are doing is reprogram the microchip in Australia. So from Cameroon, you can do that.
This web page here, I have a copy, but actually the page that Gabriel has there is a page that is inside the Wi-Fi chip here in Australia. So Gabriel, you can see that page?
Yeah, I am on the running page.
Okay, that's fantastic. So like we said before, there's a blue wire over here, and the blue wire is connected to C4. You see there's all connectors here. The blue wire goes to a relay, which is a switch. So when it activates, it will switch the lamp. So it's connected to C4. So if you go to port, go across to C4 and then select the digital out, okay, digital out like that. Then on your screen, you will see a red button, okay, if there is a signal. Can you see a red off button on your side?
Yes, we have the off button.
Okay, so C4, that means that you have activated a signal here, but the signal is off at the moment. But you can check the signal, you can check the connection. So you can check whether it's actually connected to the relay box and to the lamp. So what I want you to do is just click on the off button and see if you can change the signal, make sure everything is connected okay.
Look at what happens.
Okay, so you can see that everything is connected. So it's connected to the lamp. Okay.
The lamp is.
Did everyone see that? This lamp is here in Australia.
The lamp is in Australia, but we switch on the lamp from Cameroon. Okay.
Okay,
I can switch it off. Look at the lamp. It goes off. Okay. So you can just imagine that you are not at your house, okay, and you forget your lamp, and you can now switch off that light from anywhere, any part of the world. Okay. So can you think about the advantages of such a technology? It can save you energy. Okay. You don't need to pay for high electricity costs. Okay. Yeah. So let's go on, Miro.
So it can be a lamp, but it can also be a fan, or it could even be a pump. Okay, so that you turn on the pump in your farm because it's the water is getting low, for example, on your crops. So many things you can do. It could even be a sprinkler system because you can see a fire coming to your house. Okay, and in fact, in Australia, that's already been used for remote switching of sprinkler systems to turn them on to save the house from the fire. So many things that can be used to turn on and off. So what I want you to do is next to the C4, I want you to type in the word lamp, L-A-M-P, lamp, so just next to C4, so that we have a name. When we have a name, that means that we can control the lamp from the code. Okay, we can use that lamp word in the code. This word here is then called technically a variable, and Gabriel knows all about variables in his code. Okay, and you know that in maths because it can change. On C7, I also have another device. It's actually a sensor. This sensor is reading the light level here. So from the light here, fluorescent lamps, which tend to flicker up and down a bit, it has a white wire going in, and this has a voltage 0 to 5 volts. This can then be converted inside the microchip to numbers, because the microchip is a digital computer. Digital means numbers, so it converts the analog signal into a digital number. And how we do that is we measure the analog signal, go to C7, and we select the analog in, and on your side, on the status, you should see the digital number. Do you see the numbers on that side under the status?
Yes, we see the number. Can you see can you see this 227? It indicates the light intensity because we have a light sensor over there which functions as an input device. Okay, so it's like sending some information to the computer about the amount of light. Okay.
So the number will be higher if there's more light and lower if there's less light. So how do we put more light on my table in Australia? Can you do it from Cameroon? How do we add more light? Any of the students know? They've just seen it. Okay. So with this technology, quite easy. Just add more light onto the table.
For example, you have a lamp over there and there's not enough light on the table. Can you make sure that more light goes to the table? Is that possible? Can we do that from here? I think we just did something. Yes. What were we doing? We're switching on the lamp in Australia, right? So if we switch on that lamp, what will happen to light on the table?
Right.
It will increase, right? Yes. So you see that we are in Cameroon, that we can add more light to that table in Australia. Okay?
Yes.
And what about taking off light from the table? Is that possible?
Yes.
Okay. So let's add more light and try it. Add some more light and see if the number goes up. The number should go up. Are you still with us?
That room, what happens? Switch off the light. Okay, so that one works with maybe some body sensors. Okay, but now we are talking about light sensors. So we want to increase the light when there is no light and reduce the light when there is excess light. Okay.
Okay, let's turn on the light and see if the number goes up. Let's check.
Okay, I'm going to turn on the light.
So click on it
and
again.
Watch the number.
Yeah. So did the number go up? What is the number now on the sensor?
It increased, right? Yes. Because there was more light went to the table. Okay. Take note of the number again. I'm going to switch off the light and you see what happens. The number drops, right? Yes. Because less light has gone to the table.
What if something happens
Okay,
here in
that-
Australia? Can you see it? Can you detect it in Cameroon? If I put my shadow on the sensor, what happens to the number?
Reduces.
Okay, if I
It
cover it
reduces
more,
it.
what number do you see now?
72.
Okay, very good. And
They see
then
72, a lesser number.
16.
if
16.
something moves away, then you can also detect it. So you can detect if there is less light,
Okay, so you
the number goes down. And if there's more light, the number goes up. You can even use it to detect if
So now
someone
do
is
you-
coming near the sensor, like a thief.
Okay. So now you have a sensor which you can use to detect something. So you can use this, for example, if someone passes through that door, okay, that's the door of your classroom, okay, you can put a sensor there. Once someone passes there, the value will increase. Once someone is not there, the value reduces, okay? So it can help you to know if someone has passed there or not, or, okay? And exactly, smart, that's smart, and you can use it to make an alarm system, okay? Just with these sensors, that's very smart, okay?
So
So
now
we're going to write
next to
sensor.
C7, put in the word sensor. Sensor, so type sensor. Okay, so now we can
Okay, we're done. Let's go
use
on.
this detector to detect the light, the sensor, and then we can make some code to make the microchip automatically turn on the light. So that means it's like a little brain, artificial intelligence. Okay.
Okay.
So
So now do you see what we call artificial intelligence?
we're going to
So we
put a
want
little
to
bit of
make the
intelligence.
microchip
Yeah.
to turn on the light when there is less light and turn off the light when there is more light. So there will nobody will be there to say there is less light, let me switch off. Okay, that one is how the human works. But now we want to put this intelligence into a microchip. And that is what is called artificial intelligence. So can you understand why Dr. Penn, he said artificial intelligence is equal to microchip programming? Okay. So if you can write code for these microchips, then that is artificial intelligence. Okay.
So sorry, you can think
Okay,
about
let's-
artificial brain as the microchip. Human brains compared to the artificial brain is this is my human brain. The artificial brain is what Miro has shown you is actually the microchip. So you can see on the left-hand side of your equation, artificial intelligence is actually artificial brain. On the right-hand side is actually microchip, which is then left behind intelligence equal to programming. So therefore, left and right equation equal. Artificial brain equals to microchip programming. Meaning, any microchip you see in the world, your microwave, your fridge, your computer, is all artificial intelligence.
So, and the brain will also need instructions. So the instructions actually go in here, and it's called code on the computers, but it's actually instructions that they follow step by step. So what are the steps, the instructions that the microchip needs? It needs to first check the sensor. It needs to check the sensor and check if the sensor is below a certain level, the number. So we need to first measure the sensor. So how we do that is we put in the word if. If means that it will need to make a decision. Okay, what's inside the brackets, it will need to make a decision. So if something happens, then it will need to act. So that's the decision. Inside the brackets, now we want to measure the sensor. How we do that is we select the analog in so that it can take the input from the device, which is the sensor. So we select the analog in and it will be on the sensor. We then put the cursor here next to the round bracket so that we can then add the instruction add macro to measure the sensor. So if the analog in sensor, okay, so you have the same on yours because yours is actually controlling the microchip. Okay, so then do a backspace and we're going to say, make the decision if it is lower or less than a certain number. Okay, so what number should we make as the limit? So this means this will be the limit. When it goes below, we want to activate the lamp. Let's say we want to make the limit 120, about halfway, and then put the round bracket again. So this is the decision it needs to make. We need to check, the if means check. Check the light sensor, okay, and check if it is under, less than 120. Do you have that also on your runlink page in the JavaScript loop? JavaScript is the language that we give the instructions, okay? And the loop means that it will continue, it will repeat like a loop. So Gabriel, do you have that in your box? Hello, Gabriel. Okay, Gabriel has dropped out.
And continue.
Is just to make sure that everything is working okay on your side still.
Yeah, everything is working. I already got the status active here.
That's good. So that means you can still.
I switch it on.
Okay.
And
so the page is still working. When it reconnects, then it also reconnects to the chip automatically. So the page is working. That's good. Okay. So what I want you to do is okay. So do you have this on your screen already inside JavaScript loop? The decision to measure the light sensor less than 120. You have that already?
Yes.
Okay, that's good. So if it is less than 120, we want it to turn on the lamp. So select the turn on. Okay, and select the lamp. And then press the add macro. And you should see turn on lamp.
Yes.
Okay, so if this means that asking it to make a decision, measure the sensor, less than 120, turn on the lamp. But also we want it to do something if it's not less than 120. So to do that, we just type in the word else and press enter. And on the next line, we can put in a turn off. Okay, so turn off lamp and put the cursor under the else, press the add macro, and then you will see check the sensor, less than 120, turn on the lamp, or else if it's not, then turn off the lamp. So go up here to the page and simply press run code. Okay, on other systems, it's very complicated even just to get your instructions inside the microchip, but we don't need to worry about that. Just press run code. So is it green there on your side, Gabriel?
Yes.
Okay, so I will cover the sensor and see if it goes less than 120, what actually happens on your page. Look, the lamp is turning on. Okay, Nobody had to click the lamp.
Switch on the lamp by itself. And at first I was clicking on the button to switch on the lamp. But right
Okay,
now,
so
it just reads the signals and switch it on or off. Okay.
So the instructions to the microchip are measure my sensor, measure this sensor here. And if there's already light, turn off the lamp. So don't waste electricity, turn it off. Okay, don't need to waste electricity. But when it gets dark, then you can turn on the lamp. Okay, when it gets dark, under 120. If it goes over, turn it off. Okay, there's enough light. We can save the batteries, the solar system, or don't need to pay for electricity.
Okay.
Okay.
So did you understand why I was saying even with the solar system, we'll need a ways in which we can manage this energy. Okay, because energy is limited. We always have energy is limited. Right now we don't have electricity because there is no energy. There is electricity in other parts of the town because they are trying to not to ration, so they'll give it to some part, they will not give it to some part. So even when you have your energy, you will need to be able to control it, okay? And such, you've seen an example of how you could switch on your lamps and switch them off, okay? And it's going to save a lot of energy.
Okay, but so now we're going to go to this part of the run link. And someone there said that they also already tried to do some HTML. So HTML means that you can make a web page. So RunLink can make a web page, but on that web page you can include, for example, buttons to turn things on and off. You can include sensors. You can include measuring things, graphs, many things on there as well. So let's see how we do that. So let's say we want to create 2 buttons to turn on and off an alarm, because from our phone we want to turn it on and off in our house, because maybe we can actually create one line of code and we can even create a camera. So in our house we can see that there is someone coming and a burglar, and we want to scare them away. Let's create a simple web page. Just put in H1, this is the heading on our web page, and we're going to type in the name. How about we type in the name of your school? Okay, so type in your school name.
Okay.
Okay, so this is a web page made so your school can control the alarm, and it is an alarm control web page. So type in the words alarm control. Just using one hand, control, have the right spelling.
Okay.
Web page. Okay. And then we have a /H1 at the end. Okay, so do we have that? Are you still with us? Hello, Gabriel. Sometimes it's a bad connection.
He has less than 8 minutes left in his battery. And there's no power over there. And so it's interrupted at the moment.
I see. Okay. Has he dropped out?
Yeah, he's dropped out. So I think from what little I see there, is a very clear presenter.
Yes.
It's very, very clear. He takes his time to explain. Just a matter of practice.
Yes. He can run the training. definitely. Run it on Zoom or even better live, obviously.
Get
there
some
to show
idea
things.
whether Paula would be able to install the solar and the battery system to turn it into a smart school.
Okay, should I stop the recording then?
Yeah, for now.
Okay.